Hi, we're back again, and learning statistics keeps getting more and more exciting. Today, we're entering the realm of inferential statistics. It actually doesn't mean that we're leaving descriptive statistics behind, because we use descriptive statistics to describe our samples, and they're still useful. But we're entering the realm of inferential statistics, which is especially useful in application, and I'm going to show you why today in this video. So let's suppose we have a sample, and this looks like the samples that we've seen to this point in the class. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 observations. This is maybe a small classroom or something like that. And we go around the classroom and we ask everybody, what is your age? We write it down. And we get the age of every single person in the classroom, all 10 people. And the population that we're interested in is that classroom of 10 students. These students have a lot of variation in their ages, as you can see. So, as you'll learn in the lessons, our population means the group that we're interested in studying. And if we can get information from every single person in the group that we're studying, then we're done. We know exactly what's going on. And in fact, here we can see that the average age in our population, this classroom of 10 students, is 41.7 years old. So that's it. That's the end of the story. But what happens is a lot of times in practice, more often than not, we can't do a survey of our entire population. So we have to take a sample, and the book talks about sample. The book talks about all different kinds of samples, and I don't want you to get bogged down by that. We're going to talk about random samples mostly, and that's because when we take a random sample, it increases our likelihood that what we see in our sample will match the population. And random doesn't mean what a lot of people mean when they say random these days. Like I was bored, so I randomly made a random video, or I randomly got a bowl of cereal and ate it, where you kind of decided to do something because you couldn't think of anything better. Random has a very specific definition in science and in statistics specifically. And what it means is that every element of the population, as sociologists we're usually interested in people, but not always, every person in our population has a non-zero chance of being chosen based on the way that I'm sampling. And every single person has a known chance, and that chance is equal. So here I have 10 people. I have to know all of those 10 people. And if I want to take a random sample, I have to do something to choose the people that will be in my sample. That doesn't make anybody in here more likely to be chosen than anybody else. There isn't anybody. So if these two people here are off using the bathroom when I take my sample, this is not a random sample because they're excluded. They can't be included in my sample. If we're drawing names from a hat or something like that, and they're not there to put their name in the hat. But if everybody could be sampled, it's possible that anybody could be sampled, and they all have an equal chance. How do you create this equal chance that somebody is chosen? If you have a 10-sided die, that would do it. If you put ping pong balls in a big basket with you put names on all the ping pong balls, throw them in the basket, shake it up, and people draw up ping pong balls. Sometimes we talk about drawing names from a hat, but it may be that the names on top are more likely to be chosen. But if it's mixed up really well, maybe that's pretty close to random. And in practice, it can be tough to get it exactly random. But as long as every person in the population has roughly an equal chance of being chosen, we call this random in practice. And nowadays we have random digit generators, and one way to do that is just in Excel. You can type equal rand and then just do the open and close parentheses. and it will choose a random number between 0 and 1. You can also do rand between and then put the numbers that you want. So we could number these people 1 through 10, starting at the top as 1, 2, 3. Then we can say rand between 1 and 10, and we've chosen person number 2 for our first person in the sample. We can do it again, and we have person number 9, so this person. So there are nowadays a lot of tools out there to choose random numbers. You can go online and find random number generators as well. So here's one such site. It's called random.org. And here you put the minimum and the maximum just like we did in Excel, and you hit generate. So in this case, if we have 10 people, we can say 1 to 10, hit generate, and it's chosen person number 10, then person number 4, and person number 7. So there are a lot of tools to draw random numbers nowadays, or at least they try to approximate it. So now on to our topic of sort of why we draw samples and what inferential statistics are all about. And we're going to cut this off right here, having talked about random numbers and given some introduction into samples. And then in the second video, we'll come back and talk a little bit more about taking samples and the distribution of the means of those samples. Very exciting stuff, and I hope to catch you in the second video.